Hello friends, I am Munish Kumar, working in KCMT, Khandelwal, KCMT, Warel. Today we discuss on introductory quantum physics. Now initially in Newtonian mechanics there are three laws that is called Newton's law. The first law says that a body continues in its state of rest or uniform state of motion unless an external force is applied on it. And the second law is, according to second law, the force is directly proportional to rate of change of momentum. And the last law says that for every reaction there is an equal and opposite reaction, that is F12 is equal to F21. At present it is assumed that the crystal is made up of the leptons. A crystal is made with atom, then atom assumed to be made up of atomic nuclei, then the elementary particle and the leptons or quarks. Leptons are divided in these three groups: electron, positron, muon, antimuon, tauon, antitauon with their spins. Hadrons. Hadrons are divided into parts: mesons and baryons. Mesons, graviton, eta meson, k meson, pi meson. And the baryons are divided further into two parts: nucleons and hadrons. Nucleons, proton and neutron are called nucleons, and hadron, sigma, cascade, lambda, and omega. These are the hadrons and also called elementary particles. There are four fundamental forces which exist in nature: weak forces, strong forces, electromagnetic forces, gravitational forces. In which strong forces which acts between the quarks. The classical theory says that according to Newton's mechanical motion of object, Maxwell says light treated as a wave. Neither of these theories quite uh, work for the atoms, molecules, or elementary particles. So, what is the need of quantum mechanics? Quantum words come from the quanta, which means certain energy in discrete form, like packet. This concept was given by Max Planck in 1900, and the packet is known as quanta. Quantum theory है क्या? It is a theory need to describe the physics on a microscopic scale, that is 10 की power minus 16 centimeter order, such as on the scale of atoms, molecules, electrons, protons, etc., or elementary particles. And the need of quantum theory in earlier in the earlier 20th century, several effects were observed which could not be understood by using the classical theory or wave theory or Newtonian theory. For example, black body radiation, photoelectric effect, Compton effect. These three phenomena cannot be explained with the help of wave nature of light. Black body radiation. What is black body radiation? A body which absorbs all heat radiation of all possible wavelength incident on it and emit the full radiation spectrum on being heated. is called perfectly black body. For a perfectly black body, the absorption power is equal to the emission power is equal to 1. That is 100% absorption of the incident radiation or 100% emission of the absorbed radiation. Now the next phenomenon is photoelectric effect. Photoelectric effect when a radiation of sufficient energy is incident on a photometal, then the electron emit. This phenomena is called photoelectric effect. In this quantum mechanical picture, the energy of the light particle must overcome the binding energy of the electron to the nucleus. So, the energy of the photon exceed the binding energy and the electron is emitted with the kinetic energy, that is the photon energy minus the binding energy of the electron. This is the kinetic energy of the emitted photon, that is called photoelectron. The energy of the photon is given by E is equal to h nu, where nu is the frequency of the photon and h is the Planck constant, which value is given by this. Now photon. The quantum theory describes the light as a particle called photon. According to quantum theory, light can travel in the form of a packet which is called photon. According to the quantum theory, a photon has an energy which is given by E is equal to h nu, or which is equal to h c upon lambda, where lambda is the wavelength of the incident radiation. The energy of the light is proportional to the frequency or inversely proportional to the wavelength of the incident radiation. The quantum theory describes the experiment to to describe the experiment, whereas the classical mechanics or the wave mechanics is failed to explain such phenomena. Now the de Broglie relations. According to de Broglie, P is equal to h upon lambda. That is the momentum of a a particle is equal to h upon lambda, and energy E is equal to h c upon lambda, which means that the momentum and energy inversely proportional to the wavelength. What P is equal to mb? We know that P is equal to mb. That is the momentum of a particle. And we know the mass of photon m is equal to 0. So how it can be that the momentum is not 0? That is, the momentum of photon cannot be 0 according to these analysis. Thanks.